Bright Tuty. Every student matters.
Now let's move to these questions. These questions will also clear the concepts of circles, right? Prove that in two concentric circles. What are concentric circles? Let us say this is the center, and if I draw a circle, okay, having some radius, okay, and then I draw another circle with the same center, okay, having, let us say, larger radius. If these two circles have the same center, these two circles are concentric. So in two concentric circles, the chord of larger circle which touches the smaller circle is bisected at the point of contact. What the question says is that there is a chord of this larger circle which touches this point of contact, which touches this circle, okay. Then this point of contact divides this chord in two equal parts, okay. So let us name this center as O and this point here as P, okay, and name these as R and S, okay. These two are concentric circles. Let's look at the larger circle only. For the larger circle, this is center O and RS is a chord, right? And for smaller circle, if I draw OP as my radius, okay, RS is tangent to the smaller circle at point P, right? So OP is perpendicular to RS, right? Because the radius and tangent will have 90 degrees of angle between them, right? This is what we already know or what we have proved in the introduction part. So OP is perpendicular to RS. Now focus on the larger circle. O is the center. We are now talking about larger circle. O is the center, okay. RS is a chord, okay. And if we know that if we draw perpendicular from the center to any chord, it bisects it. It bisects the chord, okay. And OP is perpendicular to RS, so we can say that RP is equal to PS. So if you focus on the larger circle, you see O is the center, RS is the chord, and this OP is perpendicular to RS. So if we draw perpendicular from the center of the circle to any chord, it bisects it. So we can say RP is equal to PS. Hence this is proved that if in case of two concentric circles, the chord of the larger circle which touches the smaller circle is bisected at the point of contact. So what is the concept that we used here? One, that RS acts as tangent to this smaller circle, so which gave us the result that this angle is 90 degrees. And then in the larger circle, we used the concept that there is a perpendicular from the center to this chord RS, okay, and the angle between the radius and the tangent is 90 degrees. Now there are two tangents, TP and TQ, okay. And this is an external point T. Let us draw two tangents here, TP and TQ. Prove that angle PTQ is equal to twice of angle OPQ. So for these, let's name this as our center O and draw these OP and OQ. We know that this angle is 90 degrees and this angle is also 90 degrees. Let's draw OT also, okay. Now we need to find angle PTQ. So this is angle PTQ and it has to be twice of angle OPQ. So what is angle OPQ? If I draw this chord PQ, we are talking about this angle here, right? Let's name these as theta, and let's name this angle as alpha. Okay, so what we need to prove is that alpha is equal to twice of theta. This is what we need to prove. Okay, so this looks really simple. Why? Because we already know. Let's discuss it first, then we will write it. If this angle is alpha, then what is this angle here? Angle POQ is nothing but 180 minus alpha. Why? Because we know that these two angles are supplementary to each other. Okay, why? Let's write it. Because angle PTQ and angle POQ are supplementary, right? Now if this angle is 180 minus alpha, what can you say about this angle? We know that this angle is just the half of this angle, right? Why? Because we know that this angle is equal to this one. So if you take only this is half of angle POQ. So I can say that this angle here is 180 minus alpha by 2, which is 90 minus alpha by 2, right? So this angle here is 90 minus alpha by 2, and we already know about this one. This is 90 degrees, right? The chord that is joining the points of contact, and this is perpendicular to the line joining the external point and the center of the circle. This is what we discussed in the introduction. So this angle is 90 degrees. This is 90 minus alpha by 2, and this is theta. So I can say that angle which is equal to 90 degrees plus this angle 90 minus alpha by 2 plus angle theta is equal to 180 degrees. Why? Because sum of the internal angles of a triangle is equal to 180 degrees. Okay, so this is 90 plus 90 and this is 180, so these will get cancelled. So minus alpha by 2 plus theta is equal to 0. So theta is equal to alpha by 2, hence I can say alpha is equal to 2 theta, right? Which is my proof of this. Okay, so what are the results that we used here is, one, that these two angles are supplementary. Okay, another, that this angle here is 90 degrees. Okay, this is what we discussed in the introduction. So you can write the theory yourself from the introduction, how this angle is 90 degrees and why these two are supplementary to each other. Using these, we can say that this angle theta here is half of this angle alpha, or we can say alpha is double of this theta. Okay, so this is how we can prove this theorem or this question. Now PQ is a chord of length 8 centimeter of a circle of radius 5 centimeter. There is a circle of radius 5 centimeter and there is a chord PQ which is of 8 centimeters. The tangents at P and Q intersect at point T. So there are tangents at P and at point Q. These two intersect at point T. Okay, so this much is given. We need to find this length TP. So we need to find the length of the tangent, right? Now let's join these points. Let's join this here and let's join this here. What is this angle? This angle is 90 degrees. Okay, let's name the center as O, right? We need to find length TP and we are given that this length is 5 centimeter. Why? Because this is radius of the circle. Okay, so if you draw this here, then we can say that this angle here is 90 degrees. Why? Because we already know it, that this is an angle between the line joining the points of contact and the segment that joins the external point with the center. Okay, and if this is the center, and if you drop the perpendicular at any chord, it will bisect the chord. So this is equal to this. Let us name this as M. So I can say PM is equal to MQ. Okay, so both these segments are of 4 centimeter each. So this segment is 4 centimeter, this segment is also 4 centimeter, because the length of this chord was 8 centimeter. Now this triangle is a right angle triangle, so I can apply Pythagoras theorem to find length OM. What is length OM? It is equal to OP square minus PM square, which is equal to 5 square minus 4 square. So it will give you square root of this. So it will give you 25 minus 16, 9. So which is equal to 3 centimeter. So I can say that this segment here is 3 centimeter in length. Right? So this segment here is 3 centimeter. Okay? Right. So what can be the other things that we can think about? Let's look at this triangle here, triangle TPM, right, and triangle PMO. Okay, we will look at this triangle and this triangle, right. So this angle is 90 degrees and this angle is also 90 degrees. Okay. Also, what is the other thing that can be equal in these two? We know that this angle here is equal to this angle, right? Because we just proved that this angle is twice of this angle. So half of this angle is equal to this angle. So we found that two angles are equal in these two triangles. Let's name this as theta. Okay, if this is theta, then this is also theta, right? Because these are equal. Other thing that we proved equal was this angle. This angle is 90 degrees and this is also 90 degrees. Okay, and if two angles are equal in two triangles, what kind of triangles are they? They are similar, right? So triangle PTM is similar to triangle. Let's see the correspondence here. PMO. Just check the correspondence first. Angle PTM is equal to angle PMPO. It is equal to angle MPO. And what is angle TMP? TMP is equal to PMO. So what I can write here is, I am just checking the correspondence here in these two triangles, that which side corresponds to which side based on these two angles. Because in this triangle here, side opposite to angle theta is PM, right? So PM will correspond to this side OM. Okay, and this angle 90 degrees has a side opposite PT, and this will correspond to side OP. Okay, now if I make the correspondence here, I can say MPT is similar to MOP. Now you see, side MP is opposite to angle theta, and here side MO is opposite to angle theta. Now it is the correct correspondence. Okay, so this is how you will see. Now if these two triangles are similar, so we can say MP by MO is equal to PT by OP is equal to MT by MP. So what are the sides that are known to us? OP is 5, MP is 4. OP is 5, MP is 4, right, and OM is 3. OM is 3 and MP we know that is equal to 4. So now we can talk about these sides. Side PT is equal to 20 by 3, right, in centimeter, and this is what we need to find out, PT. Okay, so based on this similarity we can say that side PT or the tangent PT is of the length 20 by 3 centimeters. Okay, so this is the result.